Hi, now we start chapter 3. The section, the 3.A to 3.C, the annuity-immediate, and annuity-due. So in chapter 2, we discussed the general scheme of time diagram, and chapter 3 and chapter 4, we discussed the more specific types. So in some sense, it's more concrete and it's easier sometimes, but some examples are more complicated. And the chapter 3, the relatively simple ones. So first we discuss one example, then after that we define the annuity-immediate and annuity-due. So these are two different financial products. Okay, so example 1, assume that annual effective rate I is 6%, and what is the present value at time 0 and the accumulated value of the time at time 50 of the following time diagram. The time diagram is here. We have the time point 0 to 50. And we have the present value here. And we have actually the payment only at time 10, 15, 20. So every 5 years up to 50. And the amount is $100 each, 100, 100, 100, 100. So we have 9 payments of $100. And I is equal to 6%. So how to calculate PV? So PV is equal to the total amount, present value of this cash flow. This 100 is worth 100 times the V to the power 10. So PV is equal to 100 times V to the power 10 plus the next 100, 100 times the V to the power 15 plus 100 times V to the power 20 up to 100 times the V to the power 50. And actually, this is the similar cash flow as the example in the previous section, the 2.A, because if we think about the V to the 5th power as one number, or I would say the 5 years as a time unit, then basically it's the same example as example in section 2.A. So this is 100 times the V10s and 1 plus V5, V10 up to V to the power 40. So yeah, so this is the 100 times V to the 10th power times, so 1 minus V5 to the 9th power over 1 minus V to the 5th power. So we can just use the formula for the sum of geometric sequence to calculate this. And so this is equal to, actually, equal to 100 times, okay, so V10, 1 minus V45 over 1 minus V5. So plug in V. So V is equal to 1 over 1.06. So yeah, so this is 0.9434. So you plug in this number, then you get 274.18. Yeah, so you can get this answer. So just to make sure that this is approximately correct by rough approximation, so we have in total the $900 payment, and the PV is the present value, and these payments are on average at t is equal to 30. Okay, so then we have the 6% discount, so that we can get the 900 times 1.06 negative 30. So yeah, I think that still you have to use calculator, but this is approximate the amount. Yeah, so you can use the calculator to double check it. So that if you use the BA2 plus, you can type 1.06 to the power negative 30, so 30 negative, then that is 0.174 times 900. So that is 157. So it's pretty different, but still, yeah, you can make some guess. Maybe it's a little bit hard because we have 30 years of compounding. Okay, so how about AV? So AV is equal to PV times 30 years of interest. So PV times the 1.06, 30. So 30 years of interest effectively. So this is equal to, it's much larger. So this becomes the fifth, the PV is 274. So 5,050.45. So it's a very large number, actually almost 20 times larger. So this is the power of compounding and the power of interest. Yeah. So we want to generalize this scheme in the annuity-immediate using the definition of annuity-immediate and annuity-due. So here, just I want to mention that the PV and AV always have the same relationship here. So always AV is equal to the PV times 1 plus I to the power T. Maybe capital T, I would say. If AV at T is equal to capital T and PV at T is equal to 0. Yeah, T is equal to capital T and 0. So AV and PV are just the same question. So once you get PV, it's very easy to get AV. Once you get AV, you can get PV easily.